Hello guys, today our topic is bipolar junction transistor. The transistor is a three-layer semiconductor device consisting of either two N and one P type layers of material or two P and one N type layers of material. The former is called an NPN transistor while the latter is called a PNP transistor. So there are two types of BJT. One is PNP transistor and another one is NPN transistor. Bipolar junction transistor, here is a form like first is N, then P, then N. It's called NPN. There is three terminal. In each transistor, following points to be noted. There are two junction. So transistor can be considered as two diode connected back to back. There are three terminals, 1, 2, 3 terminals. The middle section is thin than other. You can see the middle section is thinner than first and last one. Here is N is a thinner and here is a P is thinner. Naming of transistor terminals. Transistor has three sections of doped semiconductor. The section one side is called emitter and the opposite side called collector. The middle section is called base. You can see the middle section is base, the upper section is collector and the bottom section is emitter. This is the symbol and this is the actual transistor. I hope you have seen this in your labs. First one was emitter. What is emitter? The section of one side that supplies carriers is called emitter. Emitter is always forward bias with respect to base, so it can supply carrier. For NPN transistor, emitter supply holes to its junction. For PNP transistor, emitter supply electrons to its junction. Next is collector. The section of the other side that collects carrier is called collector. The collector is always reverse biased with respect to base. For NPN transistor, collector receives holes to its junction, and for PNP transistor, collector receives electrons to its junction. And third terminal is called base, the middle section which forms two PN junction between emitter and collector is called base. Some important factor to be remembered. The transistor has three regions named emitter, base and collector. The base is much thinner than other region. Emitter is heavily doped so it can inject large amount of carriers into the base. Base is lightly doped so it can pass most of the carriers to the collector. Collector is moderately doped, or you can say collector is lightly doped. Here, the junction between emitter and base is called emitter-base junction, emitter diode, and the junction between base and collector is called collector-base junction, called collector diode. The emitter, that means you can say in another word that collector diode and emitter diode, but actually is named emitter-base junction and collector-base junction. The emitter diode is always forward biased and collector diode is always reverse biased. The resistance of emitter diode is very small in forward and resistance of collector diode is high in reverse. Reverse bias and forward bias, there is two terminology which you get to know later in this lecture. Transistor operation. Working of PNP transistor. Forward bias is applied to emitter base junction and reverse bias is applied to collector base junction. The forward bias is in the emitter base junction cause electron to move towards base. This constitute emitter current that we represent IE. You can see here and here it's IC. Collector current is going here. It's IB. Base current it's IE. Emitter current. Okay, and this is the source. This is the common base. This is a collector base. This is a emitter base. See, here is a emitter, here is a base, right? Then this junction, this area is called emitter base and this area is called collector base. Transistor operation. Working of NPN transistor. As this electron flow towards p-type base, then they try to recombine with holes. As base is lightly doped, only few electrons recombine with holes with the base. These recombined electrons constitute small base current. The remainder electrons crosses base and constitute collector current. You can see that its emitter current is equal to base current plus collector current. Working principle of PNP transistor. Forward bias is applied to emitter base junction and reverse bias is applied to collector base junction. The forward bias in the emitter base junction cause holes to move towards base. This constitute emitter current. This is a emitter current. See, here it's a battery. Here we are applying the source. Here we are applying the source, right? Here is the emitter current, base current, sorry, collector current, emitter current, base current, and emitter current. Once this is the collector and base area, this is the emitter and base area. See, here is applying emitter base junction. This is an emitter base junction we are applying, and reverse bias is applied to collector base junction. Working principle of transistor, PNP transistor. As these holes flow towards n-type base, they try to recombine with electrons. As base is lightly doped, only few holes recombine with the electron within the base. These recombined holes constitute small base current. The remainder holes cross base and constitute collector current. Here you can see the symbol. This is the emitter, collector, and base. Here you can see, as you can see, here is electron, here is a hole. Once we will apply the voltage here, okay, once we will apply the voltage, then this will push. When we will apply to the voltage, then this will push the electrons and it will recombine with the holes, and there is just few electrons and holes will recombine, other will push these electron and this will attract. This is the NPN transistor, and vice versa. Here we will apply to the reverse bias. Here it's a positive will repel to hole, then hole will recombine with electron. Sum of hole and electron will recombine, and then rest will go to this section. Here is already holes, and there is a negative terminal, and it will attract the holes. Then it will form the PNP transistor. Transistor operation modes. There is a couple of modes. Like first one is active mode. The base emitter junction is forward and base collector junction is reverse bias, called active mode, and saturation mode is called base emitter junction is forward and base collector junction is forward bias, called saturation mode, and cutoff mode is when both junctions are reverse biased. Transistor connection. Transistor can be connected in a circuit in the following three ways: common base, common emitter, common collector.